My name is Wenjing, and I'm really glad to be here today virtually talking about fence ecology and conservation. Unfortunately, I couldn't be there in person. I'm currently in Frankfurt, Germany, so a few hours time differences and also a few thousand miles on the other side of the earth. But I saw a lot of beautiful photos from the website of the valley, and I really wish one day I can visit. I assume you have heard a bit of my educational background just now. But I want to give you some of more personal story before I get started, so you can actually have some context of where I'm coming from when I talk about fences. So I grew up and I was born and raised in Hangzhou, China. It's a very pretty populated city in eastern coast China. And I did my undergraduate research study in Wuhan, which now we all know where Wuhan is, which also is a very populated city, as now you have probably learned. I spent 10 years living in the US. It's not very long, but also not short. It's the majority of my adult life I spent in the US. And just last year, I moved to Germany. So when I think about fences, it's really something that it's never a part of my life growing up, but it really is the center of my research, which you will hear more about. So I both kind of have this insider and outsider view of fences and rangeland. And I'm guessing a lot of you actually probably grew up in the rangeland system and really had a very internal view of fences. And I'm always looking for different people's living experience with fences. So if there's something that I talk about today you don't fully agree with, please let me know. And I'm really curious about learning multiple different perspectives so that I can also expand the current research that I'm doing. So I'm just going to get started. So today, most of my research about fences mostly started when I was doing a PhD in California. But at the very beginning, the reason that I even think of studying fences was really when I graduated from college in Wuhan, in China, where I took a hitchhiking trip to Tibet. So probably like a lot of people, I also did have a kind of romanticized view about the Tibetan plateau. I assuming that it's really expensive rangeland with nomadic Tibetan herders with their livestock and also wildlife all sharing this expensive land, roaming freely together. And a lot of it was true, except for when I really look deeper into the land itself, I see that there are actually fences everywhere. The yaks today, even though it is true that it used to be nomadic, today they are also grazing behind fences. So what I can see in Tibet today is not that different from what I saw in Western United States. And this is kind of shocking to me to realize that just this one single line, one thin line of fence on the land is not only shaping how animals are using the system, but also how humans are living in this system. So I expanded this interest about fences to this more academic realm. So I started to think more about it and just looking for it everywhere. And when I really started to look for it, I just realized they are actually everywhere, even though sometimes we take it for granted and we don't really see them. So as everyone here know, fences is really essential for land management, especially in the United States and in other parts of the world like Australia, New Zealand, and in Africa as well. And it's very important for roadside safety. Most interstate highway and major highways will have fences alongside it. And also another example is more and more today, as the geopolitical situation started to change, more countries are building a actual physical fence along the border, even though not all the country borders are fenced. And so the baseline here is fences are very useful in many cases. But the problem is, as we're putting fences down on the land for a specific purpose, we sometimes induce unintentional impacts. And these unintentional impacts are something that we should start to think more about, and to make sure, how do we maintain the functionality of fence for the designed purpose while minimizing these unwanted purpose, which I will talk more about. But before I really dig into the impacts of fences, I want to just briefly talk about the history of fences in the United States. As an outsider, again, it's really fascinating to learn about how fences really spread across the US, and also from the US spread across the world. And obviously the fence itself is not very new. The idea of private property and using fences to demarcate property is really can be traced back maybe toward the beginning of human civilization. And the use of fence was imported from Europe to the Americas at the very beginning, when all the settlers are in the eastern part of the United States. The landscape is not hugely different from what they had back in Europe. People built timber houses and built timber fences. But as the Homestead Act was started to be in action in 1862, people started to venture into the West and realized the landscape of the West is really kind of different from the eastern part of the United States or in Europe. There's not a lot of timbers, obviously. But the Homestead Act says if you put a house and work the land for over 5 years, then you can have this 160 acres of land. So there is a lot of need for people to put fences on this land, but you don't have timber. So now what? And that really makes people to start to think about a new way to build fences that is not very timber heavy, but maybe some new material. And most of the people who are in need of building fences at the time, they are from the farming background, because now we have these land that you started to grow crops, and then you also really want to fence out the cattle at the time. You don't want cattle to come into your land, even though at the time there are a lot of cattle roaming in the land, and the cowboy are driving them to railheads. Along the way, there's a lot of agricultural land. So it is the farmers who are really motivated to find this new way of building fences. And that kind of motivation actually coincide with the time when we actually had for the first time for the Industrial Revolution, we are able to mass produce metal material. So a natural option to build fences become metal. But the competition, the main idea of saying competition, different people trying to compete for a design of metal fence that is using small amount of metal material, but also is very effective in terms of fencing the cattle out. And what do I mean by efficiency? Really, it causes pain for when cattle push against this wire, if they feel pain and then they back away. And here I show you a lot of examples of the barbed wire design that occur in the time. And today there are a few barbed wire museums in Western United States. They're really fascinating, and you can see all these different designs of wire. You can see some of them have these blades, which use a little bit more material, and some of them is more wire focused, so they use less material. So the idea is to, again, find the kind of design that use least amount of material, but is most efficient at fencing the cattle out. So this guy, Joseph Glidden from Illinois, he is really the winner of this barbed wire design competition. He invented what we recognize as barbed wire today that literally define the Western United States today. This design is really smart. It's just a twist of barb along these along the smooth wire, and it's easy to produce and can be mass produced, and is very efficient. And actually 2 weeks ago, the the town DeKalb, Illinois, celebrated this 150th anniversary of the invention of barbed wire. There are a lot of collectors that gathered in the town and just sharing their collection of different barbs, and are really proud of this invention because, again, it really, for a lot of people, it represents the identity of the West. So fast forward today, with the invention of barbed wire of 150 years ago, today we had so many fences across Western US. From one of my work with colleague Alex McIntyre, who is now a professor at University of Washington, we modeled the fence density in the 10 states, rural area across the 10 states in the Western US. And I say modeling because we really don't have a good inventory of where fences actually are. So we use this kind of rule-based approach to do the modeling. The rule are something we know from living in the West. For example, we know between public and private land, there must be a fence. Along interstate highway, there must be a fence, etc. So using this sets of rule, we estimated the density of fences in this area. And we found that no matter where you are in Western United States, you're probably within 3.3 kilometers away from a large scale fencing. And this is, I'm saying large scale fencing because we are really ignoring all these backyard fences and fence within private lands. And in general, we estimated for over 1 million kilometers of fences. And I will say this is still an underestimate, but still 1 million kilometers is more than a round trip between Earth and Moon. Here in another example, this is one of my field study sites in Sublette County, Wyoming. This is just right outside of the Grand Teton National Park in Wyoming. In this case, I actually just open up the Google Earth and just really trace the fences as I can see them from satellite imagery. And they take forever, but at least now we have a better estimate of the actual location of fences. And in this one county alone, I mapped 7,239 kilometers of fences. Just to give you a reference, it's almost double the length of US-Mexico border. Again, this is just in one county alone in Wyoming. And we can imagine how many counties are there in Western US and how many fences we might actually have in our country. So I hope now I have fully convinced you that we have so many fences on the landscape. But does that matter? What is the impact of these fences on our landscape? So next, I'm going to dig a little bit deeper into the ecology of it. So when I first think about how fences really change ecology, especially for wildlife movement, I think, they probably just prevent the animal from crossing or not. But if we look at this video and follow this herd of pronghorn, we see that they actually, when they see the big fence, they trace along the fence for a while until the first of the leader of the herd find a easier crossing spot, and they make the cross, and all the other individuals follow. I'll play it again here. And this is showing us that even before we can think about whether animals are crossing or not crossing the fences, they actually are doing a lot of complicated behaviors in response to perceiving a fence. And this is something that we try to understand better. It's this kind of cumulative effect that these behavior changes, in addition to cross and not cross, that together is influencing an animal's use of their habitat and also how they interact with each other. And here I want to show you two additional examples of these amazing behavior changes that animals have in response to fences. first of all, so here it's this is one of my favorite example. Really, the animals, like the deer, really get used to move around this fenced landscape and cross over, and we'll also see this species differences. The sheep is just walking through and they know it's a gate while the deer are still doing the jumping. But not all species are feeling fences is a challenge, as I can show you in this example. I'm sure you've also seen cattle scratching against fences. They love, it's like their perfect scratching spot. So in order to really understand this complicated behavior change in response to fences, as I have been describing, we use animal tracking technology to track animal movement. And that means we put a GPS collar on the animals that we're interested in studying. And usually here is an example of a classic GPS collar. Usually on the bottom, the bigger part is the battery. It's the more heavy part of the collar. And then on top of it is the GPS receiver. So it's always positioning upside down. So then in this way, the GPS receiver is always talking to the satellite. And using this method, we are able to track animals and to program the collar to collect animal location information in a set time temporal interval. For example, every hour we're getting one GPS location, and we can map the animal's movement by connecting this 1 hour location dots. So now we think, trying to conceptualize how animals are gonna respond when they see a fence. Here, this gray line represent a fence. In an ideal situation, if this fence is not really a movement barrier, if the animal they can either just quickly cross it, or they are just doing some average movement that is not very different from when they're away from the fence. They might just be wanting to forage near the fence because the grass there sometimes is actually better than when it's away from the fence. So in these two cases, we don't detect any abnormality. But sometimes we'll see animals bouncing away from the fence, or sometimes they will do this back and forth movement, potentially trying to find an opening to cross the fence, or they can trace along the fence for a really long time. We actually have an example of in Mongolia, there is a very long country border between China and Mongolia, and this one individual Mongolian gazelle traced along the country border for up to 20 days before it turned away. So that is an example of extreme tracing behavior. And sometimes we have very small enclosed fences and animals might be trapped inside. And so this kind of four behavior, the one I mentioned later, we say that they are actually showing that fences is a movement barrier for these animals. So with this kind of potential categories of movement can be triggered by fences in mind, we actually developed an automatic way to classify GPS locations, as what you can see on the left side. These purple gray dots that represent GPS locations, and the yellow lines are fences. We can automatically classify the GPS location into one of these classified behavior. So we can know when and where the animals are doing the back and forth, or they're doing the bouncing. So in this way, we can actually see which fences are actually causing the problems. So now here is really looking at day-to-day movement. As they bounce to the fence, what do they do? So the question next is, how do we scale up these behavior observation to understand how, for example, they change animal migration or change their seasonal use of habitat? So to answer this question, we applied the barrier behavior analysis, as I just showed you, to this group of pronghorn and mule deer in Sublette County, Wyoming, which is, again, right next to, south to the Yellowstone National Park and Grand Teton National Park. In this case, we used 61 tracked pronghorn and 96 tracked mule deer. In this system, it's a little bit different from the valley. It's a more of a migratory system. And both species, they share their winter in this more classic rangeland system in this flatter area in the south. And as summer approached, the grasses started to green up at a higher elevation. So these both wildlife species will track these green waves and migrate to the summer range at a higher elevation. And the whole journey is about 150 to 200 kilometers. So now we can overlay the fence that I drew, overlaying with the tracked movement from the GPS collar. And then we apply the barrier behavior analysis. Then we can really see how these animals are encountering fences and what kind of behavior they're doing as they're moving up the landscape. So to summarize, we actually found that for each individual pronghorn, they might encounter fence to almost 300 times a year. And it is a little better for mule deer because they spend part of their home range in a more woody area where the fence density is lower than the plain area, but still it's almost 200 times a year. And that is just, if you are a pronghorn, it's almost like every other day, less than every other day, you have to negotiate with the fence to think about how are you going to get around it or whether you're going to jump over it. And just to remember, every jumping or trying to crawl through is extra energy that they're spending. And sometimes they're migrating when the individuals are pregnant. So this can be a very particularly a fitness influence if they need to negotiate with a lot of fences during the migration. And I know it's kind of not the best, not the great lesson that I learned from my dissertation, but still it's kind of magical when this specific result was picked up by our Planet 2 and when Sir David Attenborough was reading out this one number that is coming out from my dissertation. So that's some joy of doing science, even though it's not like the most happy number. Okay, so we so far mainly talked about movement, but movement is like one at the behavior level. But fences can really have really this impact can influence other aspects of the ecology. For example, every time when the animal try to cross, they could get entangled into within the fence, so they may get directly injured. And sometime in one population, there will be certain part of the population that couldn't really cross the fence while the adult is more capable of crossing. So in that case, we are really changing the population dynamics that can ripple through this demographic processes. And sometimes it can also influence predator-prey interaction. In the field, we have some anecdotes where wolf and cougar, they're just using the fence to corner either livestock and their prey, so it can change their predation behavior. And sometimes it can really scale up to influence the ecosystem processes. I took this photo on the bottom left in 2018 after a big wildfire in California, in Northern California. And here we can see clearly in the middle is the fence line. And on the left side of it is the land that's completely intact. And on the right-hand side is the land that is burned. So if we connect these kind of things together, from the small scale, it's changing animals' direct fitness, and it can all the way scale up through the behavior, through the population dynamics, scale up to how animals are interacting with the land and to influence the ecosystem processes and how the land is changing in response to that can then have feedback effect onto how animals are then using this new landscape. So we can see here fencing is creating a whole feedback loop across all the scales. And this is why we believe that fencing is really shaping our ecosystem today. So now we have learned a lot about fences' influence on ecosystem. What can we do to minimize these unwanted negative impacts? First of all, we have to recognize that not all fences are the same. You guys work the land, you definitely know this probably better than me. Their fences have very different structures. So most of it are barbed wire, but there's a lot of sheep ranching, at least in Wyoming. Back in the day, there were a lot of sheep ranching, so people usually use these woven wire fencing. Even though like today in Wyoming, at least, a lot of the sheep ranching are replaced by cattle, but these old woven wires still stay on the landscape. And then sometimes the barbed wire has anywhere between 3 to 6 strings, and sometimes the bottom wire can be really close to the ground. So both these kind of old fences that can be very dangly towards the ground. So either these woven wire fences or these fence with wire very close to the ground, both of them are pretty bad for ungulate, for deer and pronghorn, for their crossing behavior. It really is a barrier for them to cross. And really to address this, multiple states in the West, for example, Wyoming and Montana both have published these wildlife-friendly fencing design handbook for landowners to adapt or to think about. If you were to build a new fence or you were going to mend your old fence, maybe it's the time to think about to slightly change the design of the fence to make it more wildlife friendly. And usually these wildlife friendly recommendation includes to have the bottom wire at least certain height above the ground, and to have the bottom wire to be smooth. Because a lot of pronghorn, I don't know where the pronghorn in the valley, but yeah, maybe not. So some of the baby deer, for example, they will prefer to go under the fence, not to jump over. So these kind of smooth bottom wire is for these animals to go under fences. And the recommendation also usually include that have a top wire to also be smooth and to have some visibility design so that animals can see them from afar. And sometimes it's also good for some birds to not to avoid the collision of birds to these wired fences. And there's some other practice in addition to the design that can make the fence more passable for these animals. Sometimes the land is not always occupied by livestock. So when the land is on idle, maybe we can add these clips to make the 4-wire fencing become 2-wire fencing. So it's less of a barrier for other wildlife when they're on the path. They can it's easier for them to pass through. And sometimes people use this seasonal gate. When animals are on the land, you close the gate, but when the stock left, you can just have the gate open. So then wildlife, when they pass, it's easier for them to just go over. And there's also some let down fence. When it's in use, it's standing up, and then you can like take away a pole or using this kind of gated structure to have the fence sit down when it's not needed during certain season. So there are multiple ways that we can adapt to still have the fence on the land, but make it more passable for wildlife when wildlife are mainly on the land. And then the problem is we have so many fences on the land. How do we know where the modification should start? And this is how we can go back to the barrier behavior analysis that I showed you. If we have, from the agency's perspective, if there are some tracked wildlife, then we can use the tracking data that we have to really identify which wire of the fence the wildlife mostly interacting with. Here, as an example, we can quickly zoom into this wire that's creating a lot of wildlife fence interaction, and we can plot their barrier behavior and to find, for example, where are they doing most of the back and forth. And for that small section, we can focus our limited conservation resources to change that part of the section to be either like let down, you can put clips, or you can change the wire to make it more smooth. Usually changing a whole section of fence costs a lot of labor and money. But if we focus on a small section that we know it's causing the issue, then we can more efficiently allocate the resources. And I don't know how many of you have already heard or are already using these virtual fence. It's another very great way and slightly more technological intense but it's a very good way to keep the land shared by both wildlife and livestock. Generally, virtual fence is we are actually putting this collar on cattle as well, and then you can design a boundary on the software, or it's either on app or on your phone or on computer. You can design the boundary and say like during this time, this boundary is up, and then when the animal is approaching the boundary, they will get a sound, usually an audio alarm. And as they are approaching it more and more, eventually, if they pass the boundary, they might get a benign shock. And these kind of stimuli will force the animal to go back. But I've talked to some landowners who have already used this method. They usually say the animals will already not approach when the sound stimuli started. But in this case, we don't even need a real fence on the ground. And then you can also have the management of the herd location way more flexible. And you can actually have real-time tracking of the herd. You know exactly where they are and what they're doing. And usually the software can provide these grazing intensity maps, so you know where are they mostly grazing. So it's kind of a merging of wildlife conservation and also precision ranching. And really promotes land multifunctionality. Sometimes people can use it for recreation, and then there's no physical fence on the land. And I do know certain area is already, there are programs that grants that you can apply to adapt this technology. I know like the immediate down investment might sound a little daunting, but it has these long-lasting benefits. I'm not very 100% certain of what is the policy in Washington at the moment. So maybe either Daniel or other people can kind of, kind of look up the information and see what's the current policy there. And of course, it always takes the whole community to do any fence modification and fence removal. In the area that I work in, Wyoming, there is some local fence initiative, like Absaraka Fence Initiative. What they do is they also organize these volunteer events to get the community out on the land. And that's the exact same thing what the Conservancy is doing to have these volunteer-based events. And I participated in a couple of them. I really think it's a fantastic way to bring people together. It's family friendly, and everybody feel like you are doing some actual changes and contribution to the land that your community depend on. And of course, it's always easier to talk about it than actually to do it. And I don't feel like I have the best build for fence removal. And again, it's a good proof that we really need the community all together to make our landscape more connected. So with that, I want to thank everyone that have supported my work so far, and also thanks again for inviting me here to talk about some of my work and my experiences with fence, and hopefully it get you to think a little bit more about fences or come to the volunteer events next time, and you can try experiencing pulling wires or pulling the fence pole yourself. It's really fun, and it's immediate impact that to improve the connectivity of our land. And yeah, let me know if you have any questions or thoughts. And thank you.